Okay, let's look at first how to interpret this definite integral. So the unit of measurement for the integral from a to b, f of x dx, is the product of the units for f of x and the units for x. So think about that. If this is a rate, okay, and that's what I'm trying to find is the area underneath this rate, then my units, as it's stated here, are going to be whatever the units are for my rate and then the units for my particular variable. So here it says if R of t represents the rate at which the heart is pumping blood in liters per second and t is in time in seconds, give the units and meaning of the following integral. So again, R of t, this is a rate. So it represents the rate at which the heart is pumping blood in liters per second. The 0 and the 10 are my interval. So in this case, the integral represents the amount of blood in liters pumped by the heart between time t equals 0 seconds and t equals 10 seconds. And thus my units, though, if I had a function here and I worked this out, I am given a rate in the heart is pumping blood in liters per second, but what my answer when I work this out will just be liters. So it gives me the total amount of liters. So I always tell students, remember that this is a rate, and then when you finish, this gives you an amount. So if f of t is a rate of change to a quantity, then the total change in quantity or the amount. So if I know the rate that a drug's leaving the body and I work this integral out, then I will know how much the amount is in the body during a particular interval. So change in position, f of t, f of little t is the integral of velocity, the derivative. We just don't put the little prime there anymore. So when you see something like this and we work these, we will find the original function, which will be the antiderivative, and plug in our interval, okay, so from 0 to 30, and we always put the large number first. All right, so first we're going to just figure out how to interpret this stuff. So it says here, oil leaks out of a tanker at a rate of R equals f of t gallons per minute, where t is in minutes. It says write a definite integral expressing the total amount of oil in gallons which leaks out of the tanker in the first 2 hours. So what I'm looking at here is the total quantity is given by the integral of the rate. And this is important. Okay, so this is the rate. So here is my gallons per minute. If I had a function and could answer this, this would equal gallons. So that's my total quantity. All right, the following table gives the annual U.S. emissions, H of T, of hydrofluorocarbons, super greenhouse gases, in teragrams equivalent of carbon dioxide with T in years since 2000. What are the units and the meaning of this integral? All right, so the units are teragrams carbon dioxide equivalent, and the integral represents the total, remember this is a total quantity, of U.S. emissions during 2000 to 2002, because notice I'm just showing from 0 to 2. If I want to estimate this, and again, I don't have a function yet, then what I would have to do is I would have to do with my table, well, notice first of all, each one of these, the change in my time in year, so the change in my time is 2, and then I'm going to multiply this by my function for each value. I can get a lower estimate. So I would start at the left part of the table, 7022, 7163, 7159, and then 7048, and I get 70992, And then I can move one over, 7022 plus 7163 plus 7159 plus 7048 plus 6822. Now I wrote the word lower to make sure you realize that doesn't always mean the bottom value. Notice if you look at this overall, and certainly looking from here to here, it's decreasing, and you kind of can just compare the first and the last value because these values are going to be used for all of them. So this is actually my lower, and this is where I was saying if you're not sure, you can just do both of them, and whichever one's your larger value is your upper. And then to estimate this, well, I would just simply take and average these two values, and I get 70710, okay? And again, this information is my total amount. All right, it says a forest fire covers 2,000 acres at time t equals 0. The fire is growing at a rate of 8 times the square root of t acres per hour, where t is in hours. So this is the rate that it's growing, okay, this fire. How many acres are covered during 24 hours later? So again, we're trying to get you to read this problem and understand how to write this as an integral. So my integral here says t is in hours. How many acres are covered 24 hours later? So it would be from 0 to 24 of my rate, which is 8 square roots of t times the change in t. So remember, that's my height times the width. Well, we're not ready to know how to solve this yet, so we go back to our trusty little that I showed in the last video, my calculator here, and it only recognizes x's, so I would put 8 times the square root of x, and I would go from 0 to 24, calculate the area, and I get about 627. But we need to be careful here because if we answer the actual question, so this is the amount, this is the actual amount, the number of acres that it grew in the next 24 hours. Well, it says it covers 2,000 acres at the beginning. So I would have to take the 2,000 plus the 627, and this would be the total number of acres that the fire is going 24 hours later. All right, next is the water is pumped out of a, oops, wrong button, out of a holding tank at a rate, there's your keyword, rate, of this function in liters per minute, so I know that's a rate, or t is in minutes since the pump started. So in other words, when I find this integral, my answer will be in liters. If the holding tank contains 1,000 liters of water when the pump is started, how much water does it hold 1 hour later? But notice this says t is in minutes. So 1 hour later then would be from 0 to 60. I would put my function 7 minus 7e to the negative 0.11t. I tend to put this in parentheses. You don't have to. And then my dt. So what am I going to do? I'm going to go to my little calculator. I'm going to do 7 minus 7e raised to the negative 0.11x. Again, does it recognize t's? And from 0 to 60, and I calculate my area. It's thinking this one's a little bit harder. And I get 356.45, so that's the area underneath this rate. Again, the meaning of what we're doing. So I get, with my pencil here, I get 356.45. It says it contains 1,000 liters of water, and this is being pumped, so water is being pumped out. So that means if it started with 1,000, then I would have 643.55 liters 1 hour later. All right, so this is just getting you ready for, again, we're still using the calculator to find these values, but next we're going to figure out how can we actually find these. But the big part of this section is understanding your integral contains your rate. When you get an answer, contains an amount.